All right, today we're going to talk about special products of polynomials. All right, so here's the state standards that you need to be aware of. Also, to be successful today, you need to be able to use the square of a binomial pattern. You need to be able to multiply binomials using the sum and difference pattern. And you need to be able to solve problems using special product patterns. All right, so these patterns are very important. When you get ready to take the ACT, you will have 60 questions in 60 minutes for the math portion of the ACT. So knowing these patterns can quickly get you to factored form and be very helpful in taking a timed test. So sum and difference patterns, be able to recognize if you have the same binomial but different signs in the middle, that is a difference of squares. So you had a perfect square minus a perfect square. That's going to give you the same binomial, different sign in the middle. Here's an example. X plus 3, x minus 3. Same binomial, different sign in the middle. So the middle terms cancel, and that leaves you a squared minus b squared. So x times x is x squared. 3 times negative 3 is negative 9. You don't have to worry about the inside and outside terms. All right, so to square a binomial, you've got a plus b quantity squared. Every time that's going to result into the first term squared, you can see a squared here, plus twice ab. So ab, multiply ab, and then double that, gives you your middle term, and then plus b squared, so your last term squared. Same thing if it's a difference, so a minus b quantity squared is going to be a squared minus 2ab plus b squared. Now notice that your first term and your last term are always positive. The only difference in these is the sign of the middle term. Why? Because when you square anything, it becomes positive. So a squared is positive because it's something squared. B squared is going to be positive regardless of the sign of b because it's something squared. So the only difference is the sign in the middle. Here's an example, x plus 5 quantity squared. So I'm going to have x squared plus twice ab. And in this case, ab is your x and your 5. So a and b basically just tell you the position of the term. So twice ab plus b squared. Then you've got 2x minus 3 quantity squared. Notice that 2x, both 2 and the x is squared here. And then minus 2 times a times b, and then plus b squared. All right, so be familiar with those. Again, very important in all your classes, but also you will see those on the ACT. And knowing those by memory and being able to quickly get to an answer can be helpful on any time test. All right, example 1, using the square of a binomial pattern. All right, so again, I have these here. The more you use them, the more you will get familiar with these. Make sure you commit these to memory if possible. It will make a huge difference. All right, so it says find each product. So we're going to take the first term and square it. So to get started, let's kind of write this down. So you kind of get the process here. So we're going to take 3x. We're going to square that plus 2 times a times b, and then we're going to square the last term. All right, so 3 squared is 9. X squared is just x squared. And then 3 times 4 is 12, times 2 is 24x in the middle. And then 4 squared is just 16. All right, again, you can see that when this is a binomial that has a plus sign or addition in the middle, you notice that all of the signs are positive. All right, moving on to b. So we've got 5x minus 2y squared. That means we're going to use the pattern from the second example here, a minus b quantity squared. The only difference is there's a negative 2 times ab in the middle. All right, so if we look at this, we're going to have 5x squared minus 2 times 5x times 2y plus, again, something squared is always positive, So 2y squared at the end. All right, again, this is in parentheses, the 5 and the x is squared. So I'm going to have 25x squared. And then I've got 5 times 2 is 10xy. Times negative 2 would be negative 20xy. And then plus, remember to square the 2 and the y. 2 squared is 4y squared. Again, you can see that it is the same pattern. The only difference is now we have a negative in the middle. All right, you can see that for math practice, look for structure and a special product pattern. A and B can be numbers, variables, or variable expressions, which means it can be numbers and variables together. All right, self-assessment. I want you to take a few minutes, pause the video, and try to answer these on your own. Come back in a few minutes once you have time to answer them and see how you did. All right, for A part, you should have found x squared plus 14x plus 49 to be your product. And then for B part, 49x squared minus 42x plus 9. All right, math practice structure. Explain how to find negative 3h plus 6 quantity squared using the pattern shown above. All right, so what you can do is let negative 3h equal A and let 6 equal B. Then you would use the first one, A plus B quantity squared, to get your product. All right, D part says find the products in exercises A and B without using a special product pattern. Compare the methods. All right, remember before, in the last section or the last lesson, we did multiplying two binomials together. Well, x plus 7 quantity squared is a binomial times itself. So x plus 7 times x plus 7 can be written out, and you could use FOIL method or distributive method to find either one of these as well. It's not as quick, but you still get the exact same answer. So when it says compare the methods are slightly different, but you get the same result. Hopefully you got those and you are feeling comfortable with the square of a binomial pattern. All right, using the sum and difference pattern. All right, so you can see same binomial, different sign in the middle. This is the only time you can ignore your middle terms. If you still do your middle terms, they'll cancel out, but you can ignore the middle term. You can see over here, key idea, A plus B times A minus B, same binomial, different sign in the middle, equals A squared minus B squared. So this one's always going to have a minus in the middle. So we're going to have T times T, which is T squared. All right, and then if we do T times negative 5T plus 5T cancel. Again, your middle terms are going to cancel if you do FOIL or distributive property. So you can skip to the end and say 5 times negative 5 is negative 25. So if you do A squared minus B squared, it's always going to give you the answer. All right, so B part, 3x times 3x. So we're going to have 9x squared. And then y times negative y is negative y squared. Again, this is another simple pattern to just commit to memory. It's very handy on the ACT to be able to go quickly through some of these factoring questions. All right, can we use the sum and difference pattern for example 3? So it says use special product patterns to find the product of 26 times 34. So if you can recognize that 26 is 4 less than 30, 34 is 4 more than 30, so we can write this as a sum and difference pattern. So again, we can write 26 times 34 as 30 minus 4. Again, 26 is 30 minus 4. We just rewrote that as this. And then 34 is 30 plus 4. So what does that look like? That looks like this right here, A plus B times A minus B. Okay, so if I do that, I can quickly solve this by doing a squared minus b squared. So 30 times 30 would be 900. And then minus 4 times 4, which is 16. 900 minus 16, 884. So you can do this using mental math if you can rewrite this in easy numbers to multiply. So because that's for less than 30 and that's for more than 30, we know that we can write that as a sum and difference pattern. When multiplying large numbers, you should always look for an easy way to multiply those quickly. All right, another self-assessment. So please pause the video, take a few minutes, see if you can answer these, and then come back and we'll check and see how you did. All right, let's see how you did on these. All right, so A part, you should have got x squared minus 100. B part, you should have got 4x squared minus 2.25. C part, x squared minus 36y squared. And then D part says describe how to use special product patterns to find 41 times 39. So hopefully you see that 41 is 1 greater than 40. 39 is 1 less than 40. So you could rewrite 41 as 40 plus 1 and 39 as 40 minus 1. Then you have a difference of perfect squares.